Well, good day, everyone. This is the Southern California sector-specific drought outlook, and today is May 28th, 2026. This is our drought outlook for Southern California. This is part of our Modernizing Drought Early Warning effort, where our vision is for drought resilience in the nation's economic sectors, and using Southern California as a nice pilot to be able to do so. We hope to inform early warning decision-making based on co-developed sector-specific and evidence-based drought intelligence, and we do so by delivering these sector-specific drought scenarios each month that are tailored to the monitoring and forecasting information of our partners. So any good drought early warning effort would engage partners. And here we have, what questions do you have about drought? What topics are you considering regarding drought and its effects? What would you like to learn more about? And of course, what do you think we should learn more about? We will be expanding our pilot program that is focused on Southern California for the last 2 years to include the entirety of California and Nevada, and focusing on public health, water utilities, and agriculture. But in so doing, also continuing our focus on the entire southwestern United States, because the water resources and the affected sectors within California and Nevada, of course, are tied intimately to that entire region. So here's our timeline, a timeline for summer, autumn, and winter we provided soon as we continue the building of our Modernizing Drought Early Warning effort. But for this string of events right here, focused specifically on Southern California, this will be our final one before we continue with our expansion to the entire state of California and Nevada. And once again, the timeline for summer, autumn, and winter will be provided soon. So today's briefing, the outline is as follows. We'll begin with a global perspective, so global conditions relevant to Southern California sectors. That'll be followed by a regional perspective, where we'll cover Southwest US conditions relevant to the Southern California sectors. And then finally get into each of the different sectors that we cover: water utilities, public health, and agriculture, of course, focusing on the outlooks within those regions. I'll stop periodically to answer any questions, and either verbally or through chat if you have any. So where we begin with the global perspective, and if you've been living under a rock and not aware of the news, there's a thing called the El Nino Southern Oscillation. And an El Nino event is forecast over the coming summer, persisting into later this year. So the El Nino Southern Oscillation is composed of El Nino, La Nina, and neutral phases, and it's related to weather anomalies that we use to predict conditions in California many following months in advance. El Nino is forecast in mid to late 2026 with a greater than 90% chance after June to August, following ENSO neutral conditions in spring 2026, where we're at right now. There's a greater than 65% chance of a strong El Nino event late in 2026. Very briefly, I'll go over what El Nino and La Nina are, or not La Nina, just El Nino and ENSO neutral. So the El Nino Southern Oscillation is composed of 3 phases: a neutral phase, an El Nino phase, and a La Nina phase. So on the left here, this is the neutral phase. And El Nino Southern Oscillation, it's a coupled ocean atmosphere phenomena where at the equator, you have these trade winds, which end up blowing warm water over to the western Pacific Ocean. So the schematic on the left indicates, with the warmer colors, warmer sea surface temperature departures from average compared to what we tend to see in the central Pacific Ocean. Now, as it relates to an El Nino event, El Nino is really the reversal of ENSO neutral, where those easterly trade winds, they slacken. And because they slacken, they don't push warm water over the western Pacific Ocean. And in fact, what that causes is a lot of that warmer water to stay in the central Pacific. So when you look at this as a departure from average, what happens is warm sea surface temperature departures from average persist over the central and eastern Pacific Ocean. That leads to a whole host of effects. On the schematic, you can see that right above those warm sea surface temperatures in the central Pacific, you get more precipitation than you tend to get. What that ends up doing is it changes the amount of energy input into the atmosphere, creates a lot of waves throughout the Earth's atmosphere, and leads to some pretty significant effects. And a lot of those effects can be anticipated in regions of the globe that we focus on here, in this case, Southern California. So this right here gets into some of the typical El Nino winter effects. This is not supposed to be necessarily pertinent to the next 3 months, but all it is here is to show that when we have El Nino events, we tend to see some persistent patterns across the Earth's weather and climate. And here in this case, for wintertime, we tend to see wetter conditions and near average temperatures in Southern California. This will be a theme throughout today's presentation. The time series on the right here is a time series of the El Nino Southern Oscillation, as measured by an index called the Relative Oceanic Nino Index. This index right here measures the departures from average of sea surface temperatures in the central Pacific Ocean in a region that we call the Nino 3.4 region. And you can see where that is outlined on the left-hand part of the slide. There's a lot of different ways to measure the El Nino Southern Oscillation, but this is the one that NOAA tends to use in an operational sense, principally because it's pretty easy to use. So through time, dating back to 1950, you can see a lot of ups and downs and lefts and rights and lots of squiggles here as it relates to this time series of the El Nino Southern Oscillation. Over the last 20 or so years, we've had a lot more La Nina events than we've had El Nino events. And you can see that there with more blue shading since 2000 than you get the red shading. Over the course of our history since 1950, we've had just 8 strong El Nino events. So they're not very common. The last strong El Nino event that we saw was in 2015 and 2016. The last El Nino event did not reach that strong El Nino strength. It was just a moderate event itself. Now, in terms of the forecast, this is from NOAA Climate Prediction Center, so our colleagues who assign probabilities of El Nino, neutral, and La Nina for subsequent seasons beginning in April, May, and June, and July, all the way into December, January, and February of early next year. The vertical axis shows the percent chance of these 3 categories. The gray bar, the first gray bar on the left, indicates that ENSO neutral is the most likely ENSO phase for where we're at right now with greater than 80% probability. But the probabilities of an El Nino event increase greatly as we move through Northern Hemisphere summer and into later this year. So even by the time we're in June, July, and August, there's a greater than 90% chance of an El Nino event at that time. And looking at a lot of the indices that we focus on in order to monitor the El Nino Southern Oscillation, this event is coming on rather quickly. This right here is a chart that indicates the ENSO strength probabilities. Once again, this is released by the NOAA Climate Prediction Center. The vertical axis is the percent chance of an occurrence. The horizontal axis indicates the 3-month season of focus, April, May, and June, and July, all the way to December, January, February. That's on the horizontal axis. So the lightest red color indicates a weak El Nino. The next red color indicates a moderate El Nino. Strong El Ninos with the next hue of red, and then finally the deepest red color indicates a very strong El Nino. And as one can see, moving through time later through this year, that the chances of a strong and very strong El Nino increase quite greatly, to the point that by the time we're in November, December, January, there's a greater than 65% chance in being in either the strong El Nino category or very strong El Nino category. So that is the reason for why there's been so much information on anticipating a strong El Nino event later in this year. So the regional perspective is as follows, and I think we can all appreciate how difficult this situation is here in terms of drought, especially over the Southwest United States as it relates to snow water volumes. The first point here is that abnormal dryness is building in Southern California once again after above average precipitation between October 2025 and February 2026. Second point here, very little snow remains in the Southwest after an exceptionally poor snow season due to low precipitation and heat across almost the entire Western US. And then finally, record heat was observed throughout the Southwest since October 2025 and little precipitation in Southern California since mid-February of 2025. The chart on the slide right here indicates the US Drought Monitor drought categories. Yellow, abnormally dry; orange, moderate drought; the next orange, severe drought; red, extreme drought; and then ruby red, exceptional drought. Throughout the entirety of the southwestern United States, or almost the entirety, there's a prevalence of at least moderate drought across all of these states that are shown on the screen here. Now, Southern California had a removal of drought as it relates to the US Drought Monitor some months ago because of a sequence of heavy precipitation events that we saw dating almost as far back as October. But no, what we're seeing right now is a building in of abnormally dry conditions in Southern California and throughout the entire state more generally, to the point where in Northern California, the northeastern part of the state, you can see moderate drought conditions overspreading those counties. This is a very depressing figure, but it is from our colleagues at the NRCS, and it is of snow water equivalent in these basins, these hydrologic units across the western United States. Now, during May, we're seeing a decrease climatologically in the amount of snow that's contained on the ground. Temperatures are warming, snow is melting. But the melting snow has occurred much faster this year than it had in many prior years. And we'll get into that more in a few slides, but this is to say that very little snow is remaining on the ground throughout much of the hydrologic units that we see in the western United States, and unfortunately capping off a really lousy and just a really poor snow season across the western part of the United States. Why is this? Well, it was hot, and we haven't seen much precipitation in the Southwest, with the exception of some of the counties in California that we've been covering here. And you can see that with Santa Barbara, a little bit of San Luis Obispo, Ventura, and Los Angeles. Now, just focusing on the left here, this is a temperature percentile to date. This is for the 1st of October 2025 going through the 23rd of May. And it's a percentile rank compared to 1951 to 2024. And you can see with the deepest red color, it's been the hottest season in that set of years. This year has been across much of the West. And in areas where we haven't seen the hottest season on record, it was either the second or third hottest for that period, October 1 to May 23. On the right, this is the precipitation percentile rank to date. This is the 1st of October to the 23rd of May. And you can see that only over a really small fraction of Southern California do we see above average precipitation and quite high precipitation because of some pretty significant atmospheric rivers that were oriented in the right sort of way that led to some really heavy precipitation, where my cursor is highlighted here. Unfortunately, over areas of the United States that provide water to Southern California, most notably the upper Colorado River Basin, this is among the driest seasons on record. And not only that, we saw these conditions observed across much of the Four Corners states in addition to Nevada. Diving in a little bit further to the temporal variations in temperatures, this is maximum temperature on the vertical axis in degrees Fahrenheit. On the horizontal axis, this is time, October through the following September. The black line is the current year that we're in, and the shading indicates the maximum temperature percentile ranks based on a period of 1951 to 2024. What stands out is the very warm temperatures across several periods of this what should have been a cold season. You can see that temperatures were exceptional in December, they were exceptional in January and February, and then this March period where we were exceeding daily average highs by 8 degrees Fahrenheit, just some absurd numbers. And this wasn't just confined here to Southern California, this was the entirety of the Western United States. Just shouting out to Boulder here, we tapped 90 degrees in March right around the same time as it really, with the same weather patterns. So all told, it's just been a very warm, what should have been a cold season in the Western United States. Now, precipitation, at least as of late, has not performed in the least. So the black line here is indicating the 2025 to 2026 precipitation accumulating beginning on the 1st of October. And you can see that since the middle of February, we've seen very little in the way of precipitation over Southern California. The reason why year-to-date accumulated precipitation is as high as it is because of a couple of precipitation events that happened early in the wet season. This November event was really exceptional for November time period. Usually you don't see events like this in November. You typically see them in December and January, but nonetheless, that's what happened here. In December, there was also another exceptional precipitation event too. These two precipitation events really won the day as it relates to the seasonal accumulations, with a modest event in the middle of February and a pretty weak event for October. Now, just moving on here to the forecast relevant to drought, and I'll pause after this to ask if there are any questions from the audience. The first here is that the dry seasons began and no precipitation events are forecast for the foreseeable future. This includes the rare but possible remnants of cyclones. These cyclones, while they do deliver precipitation and they may look good on paper, they're probably a little bit more harmful than they're helpful, because they tend to produce quite a bit of precipitation that doesn't get captured in streams and reservoirs. The second point is that the Western United States is expected to experience a persistence of above average temperatures through summer of 2026. And then finally, above average autumn and winter precipitation in the Southwest United States is associated with moderate and strong El Nino events. This chart right here is just to show that we have no incoming atmospheric rivers that are forecast. And it's not really that surprising this time of year, just because we tend not to see atmospheric rivers this time of year. This is from a metric called integrated vapor transport. So it's a function of the wind speed in the amount of water vapor in the air. And the way to read this chart right here is the vertical axis is latitude, the horizontal axis is forecast time, beginning on the 12th and extending all the way through the 27th, indicating here that we are not anticipating precipitation or integrated vapor transport, whatever way you want to slice it, in Southern California. Now, moving on here into the forecast, above average temperatures in a more active southwest monsoon is forecast in June to August of 2026. So I'll just begin there on the right. This is the forecast temperatures, the probabilities of occurring in the upper tercile or upper third of the historical distribution. And you can see that throughout the entire western United States, above average temperatures are preferred. On the left is precipitation, and you can see that nice plume of increased probabilities of above average precipitation that extends from the Four Corners states northward through Colorado and into Wyoming and even into southeastern Idaho. That's related to an enhanced monsoon, and it turns out that an enhanced monsoon is something that you tend to see during El Nino events. Unfortunately, in Southern California, the probabilities don't make their way there. This right here is the frequency of above and below average precipitation and temperature related to moderate and strong El Nino events. So this includes a period of 1950 to the present. So what I was illustrating before is the increased probabilities of above average precipitation. So it follows that's the case during an El Nino event. One might say that, hey, Andy, we tend to see above average precipitation in Southern California related to an El Nino event. Well, not quite. The climatological probabilities of above average precipitation are pretty small in Southern California, so it's not something that we necessarily have to be too concerned about there. Now, moving on here to September, October, November. So this is straddling the end of the monsoon season, but also beginning the winter wet season in the southwestern United States. On the left, what's being indicated here is a slight tilt in the odds to above average precipitation in southeastern California and southern Nevada, but that above average precipitation area is primarily confined to the Four Corners states, as you can see in the left-hand part of the screen. On the right here, this is the seasonal temperature outlook and preferring above average temperatures, which is in the forecast for this 3-month season. When it comes to El Nino and its relationship with precipitation during September, October, November, what we tend to see is a tilt in the odds to above average precipitation almost over the entirety of the southwestern United States, including Southern California, Southern Nevada. So that right there is a pretty large preference, and I think that's why the Climate Prediction Center forecast is preferring that. On the right here, we have a modest increase in the chances of below average temperatures, but with temperatures warming as they have been through time, this forecast right here is probably a better indicator of what is to come rather than the climatological conditions that we tend to see during moderate and strong El Nino events. Moving on here to the all-important winter wet season that spans December 2026 to February 2027. On the left is the Climate Prediction Center forecast the chances of above and below average precipitation. The above average precipitation polygons chances are all over the southern tier of the United States. And that is really confined there to the southeast. We're not seeing much in the way of what's going on over Southern California. That may have to do a little bit with just being a little tepid about going all in on an above average precipitation forecast, given how some recent moderate and strong El Nino events have failed to deliver in Southern California. On the right-hand part of the slide is temperature related to these are from forecasts from the 21st of May for December, January, and February, indicating a slight tilt in the odds to above average temperatures there. These are composite conditions during December, January, February for precipitation and temperature. On the left, indicating a very familiar sight to many of us is the above average precipitation preference during moderate and strong El Nino events, extending from the southwestern United States throughout the southern tier into the southeast, which includes almost the entirety of California and southern Nevada, as well as some areas in the Four Corners states as well. These probabilities are rather high, in excess of 50 and 60% across many of these areas. On the right, these are the chances of above and below average precipitation related to moderate and strong El Nino events. And I would say here, just because of how temperatures have tended to be in recent years with increasing temperatures through time, that the forecast is probably a more reliable indicator than is the composite conditions during moderate and strong El Nino events. So right now, I will pause and field any comments or questions if folks have any. All right. Well, hearing none, we will move on here to our first sector, which is water utilities. There have been quite a few decisions that have been made, some human interventions that have changed the scenario a little bit since last month because we didn't have that information, or at least those decisions hadn't been made. The first one here is that reservoir and groundwater storage is expected to be average and above average in California through 2026, but will decline with increased use in mid and late 2026. Highly confident in that. Here's another scenario that we have medium confidence in. And what it says is that limited water supply remains a possibility because the U.S. Bureau of Reclamation plans to release less water from Lakes Powell and Meade in the 2026 water year. The supporting evidence is reservoir and groundwater levels are average and above average in Southern California as of May of 2026. However, with the wet season ending early and temperatures above average, more stored water will be needed throughout the dry season. The Southwest experienced record low snowpack and snow water equivalent since October of 2025. This includes key watersheds such as the Central Sierra and the Upper Colorado Basin, where record low snow water volumes is present. Above average temperatures are expected to continue through at least summer of 2026. And then finally, the Bureau of Reclamation released a drought response operations plan as of April of 2026, which aims to keep elevation levels in Lake Powell above minimum power pool levels, but will decrease the amount of water released through September of 2026. So we'll begin here with a perspective from California Water Watch, which monitors reservoir levels as of the 25th of May 2026, noting that throughout most of the state, average and above average reservoir levels prevail. Across the entire state, historical average is 114% of average, and then 32.6 million acre feet are being stored. Again, focusing on Southern California, that does not seem to be any areas where there's a big cause for concern. Well, speaking of causes for concern, this is a big cause of concern. Little snow remains after an exceptionally poor snow season across the western United States. So these are hydrologic units, and this is a map that's put together by USDA's NRCS, just to highlight that very little snow is remaining, and most of that snow has melted off. Now we'll get into some of the more regional focus areas. This here is for the San Joaquin, so moving a little bit closer to the Central Sierra here. Noting here, this is snow water equivalent on the vertical axis, and on the horizontal axis, this is time beginning on October 1st and extending all the way through the following September. The black line indicates the current year, and the shading indicates the percentile ranks based on 1991 to 2020. This was a poor year. The black line is charting out near record lows throughout much of the season. There was a little bit of recovery at the end of March, but that recovery was fairly short-lived as we saw a really quick melt-off of snow. And then we reached no snow by the time we were sometime in the middle of May. That's about 6 weeks before when we tend to see no snow, and that's based on the median value. So the snow had melted off rather quickly and in rapid fashion in the last number of weeks. Here is the Upper Colorado River Basin. So the same perspective. On the vertical axis is snow water equivalent, and the horizontal axis is time. The black line indicating that the current year was rather pitiful. Record snow water volumes in the Upper Colorado throughout much of the 2025 and 2026 winter wet season. You can see here that this period that was in about mid-March when we had all this heat in the western United States, that led to a rapid decline in snow water equivalent. And even then, we were only charting out near record lows compared to 1991 to 2020. So we were just seeing really just pitiful conditions. And where we stand right now, we are just a really, really bad shape. We wouldn't expect to see a lot of snow on the ground at this point of the year anyways, but we're going to have no snow there in short order. This here is for Lake Powell. This is end of month elevations or in their projections from the US Bureau of Reclamation. So the vertical axis shows pool elevations, the horizontal axis shows time. The thick black line indicates the observed history, what they call historical elevations. And the colored lines, blue and green and red, what those indicate are probable and most probable flows based on some scenarios that they run through their Monte Carlo simulations. What the big takeaway from this as of last month was that Lake Powell would fall below minimum power pool levels by the time we reach the end of summer 2026. So basically by September of 2026. What ended up happening, though, is a drought response operations plan. The U.S. Bureau of Reclamation, as well as the upper states, enacted a response plan. And that response plan is meant to maintain Lake Powell above those minimum power pool levels. So what interventions did they take? The first one is on the left. That's the Flaming Gorge Reservoir. And they've planned to release 660,000 acre feet to approximately 1 million acre feet toward the southern states and to help maintain Lake Powell. On the right, that's Blue Mesa Reservoir. It looks really beautiful. On the bottom right, this is Navajo Reservoir. Releases are possible there, depending upon how low lake levels in Lake Powell go. But they have agreed to Flaming Gorge Reservoir releases, and they have potentially planned possible releases from Blue Mesa and Navajo. So the two charts on this screen, I showed the one from before from April of 2026. The one on the right is the updated projections from May of 2026, which takes into account the drought response operations plan. So the main takeaway here is that none of these lines, none of these potential outcomes fall below minimum power pool level. One thing that is important to note here, however, is that the releases from Lake Powell have been updated. So as of last month, April of 2026, Lake Powell release was planned to be 7.48 million acre feet. That's been revised under this response plan to 6 million acre feet. So there's going to be less water released from Lake Powell and less water available to the downstream, just based on these updated projections, which again are meant to keep Lake Powell above minimum power pool level. Okay. Well, let's finish up there, and I invite any comments or questions if folks have them.
So can you go back a slide?
Sure.
What's the like the bump in like at March 2027 to April? Are those expecting the expectations from a super El Nino or just average expectations?
They include many different iterations that involve, some have super El Ninos, some are near average conditions, some are below average conditions. So this is composed of many different simulations that include different behaviors of the weather and the climate from a historical sense. So this right here would probably be a super El Nino of the past. This here would probably be a really poor year in the past. But they do have a bump up here because typically when we have really poor years, we tend to see a bump up, this year notwithstanding. Does that answer your question, Roger?
Yeah, I just didn't know if the that last part did, that the blue line is maybe expecting a super El Nino and
Yep.
the red one is just not.
Yep.
But it seems steeper than any of the other ones in the past. So
yeah, I think there's some management decisions that are being made over in here because you can see that they've the releases have been updated here. So you can see that this release for water year of 2027 will be 8.76 million acre feet compared to 7.69. So if they were to release only 7.69 from Lake Powell, you'd see a bigger bump here as you would in the April projections.
got it. Thanks.
You're welcome. Okay. Well, let's move on here to public health, where I think a lot of the same concerns prevail from last month as they do this month. The first one is poor air quality due to blowing dust is expected from April to June of 2026, high confidence. The risk of poor air quality from wildfire smoke will increase in summer and autumn amid warm temperatures in the dry season, highly confident there. Valley fever cases are expected to rise in spring, summer, and autumn of 2026. After drought, then recent heavy precipitation, then recent dryness once again, conditions are favorable for the valley fever fungus to thrive and spread in dry and windy spring. And then finally, there is a high risk of heat-related illness in Southern California and throughout the Southwest between spring and autumn of 2026. And we have several lines of evidence here. The first is there's an increase in the airborne dust is expected due to intermittent winds in spring of 2026. Above average temperatures forecast during the dry season in spring and summer will increase the risk of wildfire and wildfire smoke in summer and autumn 2026. Heavy precipitation following drought will allow the valley fever fungus to thrive and thus blow around. And then finally, above average temperatures in periods of extreme heat are forecast in spring, summer, and autumn of 2026. This right here is the air quality index and wildfires as of earlier today, May 28th, 2026. And you can see that throughout much of Southern California and the Southwest, good air quality prevails. But there is a lot of fires burning in Southern California. And we'll provide a little bit more context to that just based on what we're seeing from remotely sensed situation on the ground at the land surface. And speaking of which, browner than average conditions indicate a dwindling of vegetation health consistent with the active wildfires that we showed on the prior slide. This is called the normalized difference vegetation index. It's essentially showing anomalously green or brown conditions in Southern California. And you can see that throughout much of Southern California, anomalously brown conditions are prevailing, especially in the San Diego area where precipitation has been quite a bit lower than the rest of the region, but also exceptional heat, as well as it being so long since we saw any precipitation, is really a recipe for problems as it relates to vegetation health and the ability to sense greenness and brownness from satellites above. This right here is the significant wildland fire potential for June 2026 on the left, July 2026 on the right. This is produced by the National Interagency Fire Center. So anywhere that you see red, it's an above average significant wildland fire potential. So the four corner states are being noted as an area in June of 2026. And then for July 2026, also noting many areas in the west and southwest US. This removal of these polygons here for above significant wildland fire risk is probably consistent with the perception that a monsoon, as it moves northward through Arizona and New Mexico, will begin to reduce the risk of wildfires. Interestingly enough, what doesn't show up here is Southern California in June and July. And I'm not so sure if that's consistent with conditions that we're seeing on the ground, whether that is the fires that are being reported or the anomalous brownness or greenness. But I do think that there is some risk of wildfires in Southern California as we move through summer and certainly into autumn before any precipitation begins to fall during the next wet season that nominally begins in October of 2026. With drought, then heavy precipitation, then dryness again, comes a whole host of conditions. The valley fever fungus thrives in conditions, in these wet conditions. And now with the land surface really browning down and becoming quite a bit drier, valley fever and all kinds of things in the soil are able to blow around and affect people. And this season is a good example of that. This right here just gets into Southern California's highest winds are often observed in March to June. So the vertical axis is wind speed, the horizontal axis is time, and you can see where we sit right now toward the end of May is we are in the time of year where we can see the highest winds that we typically see in Southern California. This right here is a forecast of conditions over the next few weeks. So the top panel here, this is a daily average wind speed in Southern California. And these are just box plots that are aggregating information from forecasts here. So on the first day of the forecast, which was Tuesday, the median value of that day was about 8 meters per second with some spread around that value. These windy conditions are forecast to subside by this weekend, but then have a chance of increasing once again as we move into next week. One important thing to note here is that temperatures through this week are forecast to be fairly moderate in Southern California. Then as we move into next week, the heat really builds back in, and we're talking about daily average highs exceeding about 35 degrees Celsius in Southern California. So that right there is an obvious cause of concern within the region. Now, as we move into later in this year, really the noteworthy aspect from a public health standpoint is heat, and these temperature forecasts really calling for a continuation of warm temperatures as we move through summer and into later in this calendar year. So I will conclude there and ask if anybody has any comments or questions. Okie dokie. Well, hearing none, we will move on here to the agriculture sector. So less water may be available for irrigated agriculture in 2026 and 2027, which would reduce agricultural productivity. This right here is related to less water being planned to be released from Lakes Powell and Meade by the U.S. Bureau of Reclamation. As far as I know, those details have not been worked out, but it certainly remains a possibility. And then above normal temperatures and periods of extreme heat will likely affect agricultural workers, decreasing their productivity. And that follows on from the temperature forecasts that we've so heavily cited. In terms of annual rangeland forage production, we're coming to the end of that season. And this has, by all accounts, been a very good season because we saw quite a bit of precipitation in October, November, December, and a little bit in February. That led to really nice conditions on the land surface leading up to that time. That happens to be the time of year in which we get the most rangeland forage production. So the weather and the climate did behave in a way that is conducive for above average conditions for this year. But unfortunately, where things stand right now is, and we showed this previously, is anomalously brown conditions on the land surface right now. What that would require is for irrigated agriculture, for there to be more irrigation. So conditions are in worse shape than they were before. On the left, this is a cropland map for rain-fed crops, irrigated crops, and then mixed cropland. That's compared on the right to the normalized difference vegetation index, which is indicating a building in of anomalously brown conditions over Southern California, which includes irrigated agricultural areas. Now, a reason for why conditions have been so extreme in the land surface is temperatures, but that is not necessarily what a plant or the land surface feels. They feel the demand of water by the atmosphere, which is in part caused by temperatures, but also by wind speed, anomalously sunny skies, and the lack of moisture in the atmosphere. And you can see here that these yellows and oranges and reds, they're indicating anomalously high drought conditions as it relates to the increased evaporative demand. That is, the demand by the atmosphere from the land surface and plant transpiration. Not only has this been an issue over Southern California, the Western United States, you can see this across much of the central United States, moving all the way from California eastward through North Carolina and Virginia. It's been an anomalously high evaporative demand time of year, and this is as of the 21st of May for a 3-month period ending on that date. We're expecting a continuation of anomalously warm temperatures throughout the summertime. And where we stand right now is we are continuing to move into anomalous or climatologically warm conditions and warming conditions as we move into June, July, and August. And with the expectation where temperatures will be above average temperatures in Southern California are typically over about 100 degrees. That clearly produces quite a bit of stress, and that is our expectation for this coming summer. And then as it relates to temperature and precipitation, temperatures above average during the summertime, not indicating a tilt in the odds to above or below average precipitation in Southern California during June, July, and August. Sometimes, at least in far southeastern California, we can see above average precipitation related to the monsoon, but there's no indication of that here from the forecast that's been released by the Climate Prediction Center. As we move into later in the year, the expectation for above average precipitation in Southern California is a real one, and it's a byproduct, or at least an indication from the El Nino forecast. So that right there has some cause for optimism as it relates certainly to agriculture, especially that rain-fed agriculture in the southern part of the state. And once again, just summarizing here that there's a little bit of uncertainty related to the amount of water that may be available to irrigated agriculture because of fewer releases and less releases from Lake Powell as we move later into this calendar year. So we'll end the agriculture section there and open it up to any comments or questions if folks have any. All right, well, hearing none, I'd like to thank everybody once again for joining, and we'll sign off until next month.